Uh, Today, class is basically what is the automata theory, and we learn here the automata theory, deterministic finite automata, as well as the non-deterministic finite automata. So, what is automata theory is basically automata theory is a field that focuses on studying the abstract machine to understand the capabilities as well as the limitation of computations performed by analyzing the mathematical model of how machine can perform the calculations. So in one line, an automata is an abstract model of a digital computer. So what is automata? Automata, an automaton is an abstract model of a digital computer. Now, what are the characteristics of an automata? So now the of automata characteristics of automaton are: first, it is input means at each of the discrete instant of time, say t1, t2, tm, the input values i1, i2, ip, each of which can take a finite number of fixed values from from input alphabet, this sigma. Now what is output? What is output? So output is basically, suppose 1, O2 and OQ, and suppose OQ are the output of the model, each of which can take finite number of fixed values from an output from an output O. Now the state, third characteristics is state. So at any instant of time, the automaton can be in on of the state, say Q1, Q2, suppose Qn. Suppose in there are n number of states. So at any instant of time, the automaton can be in on of the state Q1, Q2 to Qn. Now the third characteristics is state relations. So the next state of an automata at any instant of time is determined by the present state and the present input. So next state of an automaton at any instant of time is determined by the present state and the present input. And the fifth characteristics is the output relation. Output relation. So now the output, this output is related to either state only or both input and the state. For example, uh, for example, suppose we have a 4-bit SIP register which is basically designed by using the D flip-flop. Suppose this is a 4-bit SIP register which are basically designed using a D flip-flop. Suppose all are the D flip-flop and there is a serial input. This is the output and these are connected to this, and these are the serial output. This is a serial input and this is serial output. All are connected to clocked. All are connected to the clocked, right? And all are the D flip-flop and serial output. So it is basically a 4-bit. It is a 4-bit shift register using D flip-flop. Now, how many states will be possible in this shift register? The It is a 4-bit, so the shift register have basically 2 to the power 4, that means 16 states. So the states, how many states? It will be 2 to the power 4, that is 16 states ranging from 00 to 111. These are the possible states. And uh, input. So now the input is, so the one serial input and one serial output that I have mentioned. So the input alphabet. So the input alphabet is basically sigma, which are basically taken either 0 or 1. The output alphabet basically set O, which are also basically 0 and 1. Now the 4-bit SIP register can be represented as, suppose this. So here the inputs I, here the output is basically O, and the machine Q1 to Q2 up to Q16, total 16 number of states, and it is basically a representation. That means we can represent this 4-bit SIP register by using this. These are the inputs These are output, and at any instant of time, discrete instant of time, the automata can be in any one of the states, uh, Q1 to Q0, because there are 16 number of states. So any sequential machine behavior can be represented by an automata. So that is any sequential machine, basically the nature is sequential. The sequential machine behavior can be represented by an automata. Now we'll go for discussion of some uh, notations, are basically basic terminologies which are basically important and frequently used in the theory of computation. So the terminologies: some terminologies. So first terminology is a symbol. What are symbols? Symbol is basically the smallest building block, which can be any alphabet or letter or any picture. So symbol is the smallest building block which can be any alphabet or letter or any picture. For example, A, B, suppose C, 0, 1, all are basically the symbol. Now alphabet. What are alphabet? And basically it is denoted by some symbol this. So alphabets are set of symbols. So alphabet are set of symbols. Set of symbols which are always finite. Which are always finite. Example, suppose this sigma is equal to 0, comma 1. So it is basically an alphabet of binary digit. Similarly, we can write alphabet 0, 1 up to 9. What is this? It is basically an alphabet of decimal digit. So is an alphabet of binary digit and is an alphabet of decimal digit. Now the terminology string, and string is a finite sequence of symbol from some alphabet. We can define a string as string is a finite sequence of symbols from some alphabet. And these string are basically we can denote it as a w, and length of the string is basically denoted by this symbol. So, and also empty string can be denoted as by basically this epsilon symbol, empty string. Yeah, so it is a string, it is the length of the string, and it is the empty string. Now, suppose for example, we have suppose we have uh, alphabet sigma is equal to a comma b, and we want to generate string of length 2 by using this alphabet. So how many strings are possible of length 2 using this alphabet? So obviously uh, the strings over this alphabet can be AA, AB, BA and BB, each of which of length 2. So the number of string will be here, it is a 4. So now if, so we can conclude, if the number of sigmas, if the number of sigmas is represented by this symbol, that is the length, then number of string of length n possible over this sigma is equal to, we can write in that way, to the power n. So this is the general formula if we have this. Now, what is language? Language is basically a set of string. We can define language is a basically a language is a set of string chosen from some sigma star. So this sigma star is basically set of all string. Sigma star is basically set of all string. So a language is basically a subset of this sigma star, or a language which can be formed over sigma. It can be a finite or it can be of infinite. So we can write a language a language which can be formed over sigma can be finite or infinite. Can be finite or it can be infinite. For example, suppose this is the language L1. We can write, suppose, set of all string of length 2. That is where this sigma is equal to, we can say, suppose AB, right? Where that means the language will be generated over this sigma. So set of all string of length 2, obviously it is a finite language, because we know the set will be AA, AB, BA and BB. These are the possible strings uh, of length 2. So obviously it is a finite language. But if we write, suppose L2 is another language, set of all strings, we can write in that way. We can write set of all strings which starts with a here also this sigma is equal to, suppose, AB. So now, so any number or or the string that are possible by using this set of all string which starts with a, by which are all strings which are basically starts with a, so it can be infinite. For example, we can write sub strings a b a b b a b a, etc. So obviously it is a infinite. Now, more specifically, we can say that sigma star, we can say that this sigma star is basically a universal set, is basically universal set. Now, if we can say, suppose say sigma equal to AB, alphabet is AB, then what will be sigma 0? Means string of length 0. That means set of all strings over sigma of length 0. So we can write set of all string over sigma of length 0. That is, it is basically epsilon. Similarly, we can write, it means set of all strings over sigma of length 1. So we can write this here, only the length 1, set of all strings over sigma of length 1. Obviously it will be AB, right? So now similarly we can write this, it means set of all strings over sigma of length, here it will be 2. So what are the strings that are of length 2? That means AA, AB, BA and BB. So in general we can write in that way, a sigma star is basically set of all string, is basically we can write in that way, sigma 0 union sigma string of length 1, it means string of length 2 and so on. That means epsilon string of length 0, then AB, string of length 1, then string of length AA, AB, BA, BB, and so on. This is string of length 2, string of length 1, and string of length 0. This is string of length 0, string of length 1, and string of length 2, and so on. So it is infinite. So now these are the basic terminology that we will focus during this course and will be repeatedly used. That's why we have discussed in this lecture basic terminology, what is finite what is automata, and some terminologies. Thank you.